So the figure above shows the graph of f. It's a piecewise function, linear. For negative 4 to 12, the function g is defined as g of x is the integral from t to x f of t dt. So this is another one, right? G of x is the integral of this. So what does g of x represent? G of x is the area, right? Yeah, under the graph or between the graph and the x-axis, but starting at x equals 2, right? That's the important part, okay? So if your x is a number greater than 2, then you're in the area. But if your x is something less than 2, then you're going backwards. All right, that's the important. That's the key part here. Does G have a relative minimum, maximum, or needle at x equals 10? Okay, so for part A, we want to show that we understand this relationship, right? So if you want to find min-max of any quantity, you need to look at its derivative, right? So we need to consider g prime of x. And we know that g prime of x is just f of x, right? And so we want this exclusively on x equals 10, which is here. And now look at that region, x equals 10. So g prime, right? When do we have a minimum or a maximum? When g prime goes between positive and negative, or negative and positive, right? But look at g prime at 10. It's negative before, it's negative after. So since f of x does not change sign, at x equals 10, there is neither a minimum or a maximum. Okay? You guys get the idea? BF, does the graph of G have a point of inflection at x equals 4? Well, now I want G double prime, right, for point of inflection. G double prime of x is equal to f prime of x, okay? And so let's take a look at f prime of x at x equals 4. Does f prime change sign at x equals 4?
No.
F prime.
Yeah, because
F prime is the slope. Yes, it does. So yes, there is a point of inflection because f prime of x changes, I'm sorry, not f prime of x, f of x changes from increasing to decreasing. Okay, look at how we're going to justify this. At x equals 4, meaning f prime of x changes sign at x equals 4. Alright? So we didn't just say f prime of x changes sign because we're not given f prime explicitly. Okay? We're given f. How do we know f prime changes sign? Because f changes from increasing to decreasing. So you always got to go from what you have to what you ascertain, right? So this is increasing, changes to decreasing. That means f prime changes sign. That means there is a point of inflection because f prime is equal to g double prime of x. It all has to connect. C. Find the absolute minimum value and the absolute maximum value on the interval negative 4 to 12. Okay, this looks like a closed interval, huh? And we want extrema, so this is EVT, extreme value theorem. So, first we have to find the critical points. We have to find where g prime is equal to 0, right? So g prime of x, which is equal to f of x, is equal to 0 at x equals what? Negative 2, 2, 6, and 10. But what is it that we want here? Absolute minimum or maximum. Do we need to consider 2 or 10?
No.
Is there a minimum or a maximum? We said there was nothing happening here because there was no change in sign. It's the same here. No change in sign. Okay? So the only things we have to look for is we need to find g of 0, g of, no, not g of 0, I'm sorry. I wanted to do the endpoints first. Negative 4, 12, and then, what did we say? Negative 2 and 6. Yeah. And then g of 6, I'll write that in a minute. So, what's g of negative 4? G of negative 4, alright, so the area is defined starting at 2. Okay? G of negative 4, that's the area from 2 going across, going to the left. So now look, basically I want all of this area. But do you see that, all the way here, right? Do you see that this and this will cancel each other out? So basically all I need to find for this is this area. And that's half times 2 times 4, which is 4. However, because I'm going in the left direction, it's negative 4. Is everybody okay with this? Very important. It's becoming a theme. Okay. G of 12, now that's the area starting at 2 and going over all the way to here. Okay? Alright, so take a look. The area here is 8. The area here is 8. The area here is 4. So if I want to go from 2 to 12, the 8's cancel, so it's just negative 4. G of negative 2, alright, the area here is also 4. So what's G of negative 2? Negative 8. And then what else did we want? G of 6. What's G of 6? 8. So what do we want here? Absolute max at G of 6 equals 8. Absolute min at G of negative 2 equals negative 8. D. Find all intervals for which g of x is less than 0. Right? And again, we're just gonna scan, do the same thing. So again, my starting point is negative 2. And it says when it's less than or equal to 0. Okay? So, starting at negative 2, if I start moving to the left, our area is negative, 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 and then here it's still negative, right? So it's negative in the region from negative 4 to 2. Now technically at 2, what's the area? 0, but it says less than or equal to 0, so we're good. And then now if I go to the right, positive, positive, here it becomes 0 at 10, right? The area becomes 0 at 10, and then from 10 to 12 it's strictly negative. So 10 to 12. Again, we can close the at 2 and 4 because it wants to equal to 0. Is that a problem? This one was actually kind of fun. I think I'll stop here today.